In this lesson, we will be talking about intermolecular forces. So this is intermolecular forces, so short for IMF. Okay, so the inter means it's between two molecules. So the way I remember it is that you're a person and another person, you are interviewing each other. So it's what's happening between two substances. They're molecules, sometimes they're atoms. It could be a force between a helium atom and another helium atom, okay? As opposed to a force between a hydrogen molecule and another hydrogen molecule. So it's the force between substances, okay? So the intermolecular force is based solely on the polarity of a molecule. So a polar molecule, an example of a polar molecule is water. Since water has a bent shape and oxygen is more electronegative, the electrons will be pulled towards the oxygen, causing a vector force in this OH bond and a vector force in this OH bond. These two vector forces will add up to each other, causing the electrons to go up towards the O, giving oxygen a partial negative charge and hydrogen a partial positive charge. Because water has a negative and a positive end, it is polar. Okay, let's do another example. This is carbon dioxide. Carbon dioxide is nonpolar. Okay, even though the carbon-oxygen bond is polar, where the electrons will go towards the oxygen because it's more electronegative, there's a vector force pulling to the right, and in this CO bond, the electrons are also going towards the right. But since these two vector forces will cancel each other out, this molecule is nonpolar. It has no positive or negative end. So this molecule, it's neutral everywhere. No positive, no negative, as opposed to this molecule has a partial negative on the O and a partial positive on the right. Okay, what is electronegativity? So you have to understand which substance is more electronegative so you know where the electrons are going in a molecule. Electronegativity is the ability of a bonded atom to attract electrons to itself. In this case, oxygen is bonded to H. It's the oxygen's ability to pull electrons towards itself. The trend in electronegativity in the periodic table goes like this. As you go to the right of the periodic table, the atoms get smaller. As you go down, it gets bigger. Therefore, this substance, the smallest one, is most electronegative because it's small. The electron can get close to the nucleus. Okay, so the most electronegative atom in the periodic table is F, then O, then N. Okay, so you have to consider those three as very electronegative. Okay, so draw a water molecule. I did that already, so it would look like this. Sometimes I draw a circle showing the partial negative pole on this side and a partial positive pole on the hydrogen side. Okay, so sometimes you will hear the word intermolecular force versus intra. Okay, so now you're getting a little bit confused. Inter is between two people. You are interviewing each other. So in this example, this is oxygen here, and this is hydrogen, and this is hydrogen. Okay? Intermolecular force is this dot, dot, dot force in between them. Okay? As opposed to intra is the force inside, which is the force inside in between the O and the H, which happens to be in this case a covalent bond. So covalent bond is an intramolecular force. So let's talk about intramolecular forces. What are they? Well, here they are. Intra. The first one is a covalent bond. That's an intramolecular force. In this example, you have a covalent bond between the C and the H where they're sharing electrons. Another intramolecular force is a metallic bond, shown here. So it's the bond inside the atom, it's inside the substance itself. Okay, another intra is an ionic bond. So the bonds that we learned in first semester, ionic, covalent, metallic, are all intra. Okay, now you might wonder, what about intermolecular forces? What are the different types of intermolecular force? We will be studying 3 intermolecular force in this lesson. Okay, the first one is called a dipole-dipole force. A dipole-dipole force is a force between 2 substances that have poles or polar. It's a force between substance that is polar and another substance that is also polar. Okay, an example would be water, HOH. And since this is negative and this is positive, it's going to have a force between water, which is also polar. This is negative, this is positive. Okay, that is a dipole-dipole force. The reason they call it dipole because water has dipoles, 2 poles. This water also has a dipole, 2 poles, positive, negative. Therefore, it's called dipole-dipole. Okay, the other one is called ion dipole. And this is how salt, like sodium chloride, is dissolved in water. As you can see, sodium here is an ion, Na plus ion. As water goes into this ionic lattice structure, the oxygen part of the water, which is partially negative, will have ion dipole forces with the sodium ion and pull it away from the lattice, therefore dissolving it. The same is true with the Cl minus, where the partial positive H will pull it away from the crystal lattice, dissolving that as well. Okay. The last one is called a dispersion force. So let me just, okay. So dipole-dipole is a bond between 2 polar substances. Okay. Just separate those. Ion dipole is a force between an ion and something that is polar or something that has 2 poles. This is ion dipole. And I ran out of room for the dispersion. And dispersion force is predominant between nonpolar and nonpolar substance. It is predominant. Okay, let me tell you what I mean in a minute. Okay, so for example, helium is just a monatomic gas, doesn't have any polarity, it's just an atom by itself. Can have, and it's nonpolar, so once you turn that gas into a liquid, it will have dispersion forces. So it is predominant in nonpolar molecules. Just a disclaimer though, dispersion forces are present in all substances. So dispersion forces can be in in polar substances as well, but it's predominant in nonpolar. Okay, to summarize, dipole-dipole is between 2 polar substances, ion dipole between an ion and something polar, dispersion, nonpolar and nonpolar, but present in all substances, but predominant in nonpolar.